Okay, hello everyone. Now that's a fourth flip-flop, that is a T flip-flop. T flip-flop is also known as toggle flip-flop. Okay, it is also known as toggle flip-flop. Now, why it is named so? As you all know, in JK flip-flop, we have a toggling condition. Do you remember the states when there was the toggling condition? It was when J equals to 1 and K equals to 1. So, if we just require the toggling condition, the J equals to 1 and K equals to 1 state, there is no need to use the whole JK flip-flop. We will just directly use the T flip-flop. T flip-flop is very simple. It is the JK flip-flop and the both inputs are connected to each other. Like you remember in D flip-flop, it was a NOT gate here, and in JK flip-flop there is no NOT gate here. The inputs are directly connected to each other. So I have written here, if we want only the toggling state, we use T flip-flop instead of JK flip-flop. Okay, and now this is the block diagram as we did in the D flip-flop, and this is the whole circuit diagram. As you can see, it is totally a JK flip-flop. There are 4 NAND gates, the outputs are feedback here, and this QN bar is going to the input, this QN is going to another input of the NAND gate, and J and K both are connected to a input, and that input is known as the toggle input. And there is a clock pulse, and obviously you all know if a clock pulse is high, that means it will be operated, otherwise it will not be in the operation. If the clock pulse is 0, this will not going to work. And this is the characteristic table, and this is the truth table. Okay, so I'll explain you how to make the characteristic and the truth table in the last when I will finish explaining you. So here I have made case 1, case 2, because this is a T flip-flop, only one input. So if there is only one input, then there will not be many combinations and in the characteristic table, you know, there are two inputs QN and T. So if there are QN and T, that means there are two inputs and there will be 4 combinations. Okay, so case 1 equals to T equals to 0. So here you can just see here, this is the JK flip-flop. I have written here T equals to 0. So if T equals to 0, that means this input is also 0 and this input is also 0. The working is very interesting. So, and you all know the output of the NAND gate. If any of the input is 0, the output is 1. So this is 1, this is 1. Okay, we have to determine QN plus 1. Okay, so what will be QN plus 1? So you all know it is 1 into this QN bar. This QN bar is going here. So 1 into QN bar whole bar. So it will be QN. That means the next state is the same as the assumed output. That means if the assumed output is 0, the next state is 0. If the assumed output is 1, the next state is 1. But remember, it is valid for the case if T equals to 0. Okay, now the case 2, if T equals to 1, I forgot to write here T equals to 1. So it is well understood. The next case is if T equals to 1. So I have applied here, 1 is here, 1 is here. Clock pulse is 1. Okay, now if both of the inputs are 1, so we have to see what is the another input here. So this input is coming from here. So this is QN bar and this input is coming from here. So this is QN. So at this gate, I have written here G1, output at G1, output at gate 1. What will be the output? It is 1 into QN bar whole bar, because there are 3 inputs to this NAND gate. The one input is 1, another input is QN bar, and another input is 1. So it is 1 into QN bar whole bar. So the output will be QN. So QN is going here. Output at gate 2 here. What will be the output at gate 2? So you can see one input is clock pulse is high, that is 1. Another input is T input, T equals to 1 because we are considering case 2. So T equals to 1, 1 is going here. And another input is Qn. So this is Qn. So Qn is going here. So what will be the output at gate 2? It will be 1 into Qn whole bar. So the output will be Qn whole bar. Okay. So we have determined the output at gate 1 and gate 2. Now what will be Qn plus 1? Output at gate 3. You can easily find from here. So we have to assume either Qn equals to 0 or Qn equals to 1. So if we have assumed Qn equals to 0, that means Qn plus 1 bar equals to 1. That means the output here. So if we have assumed Qn equals to 0, if we have assumed 0, that means obviously the output will be 1 here, and Qn plus 1 will be Qn bar. Okay, so the output is 1. So remember, if T equals to 1, and Qn equals to 0, so output is 1. If Qn equals to 1, T equals to 1, output is 0. That means it is the inverse of the assumed output. So we can see here in this table, we can see here in the characteristic table, Qn, like in the case 1, if T equals to 0 and T equals to 0. So assumed output was 0, so the next output will be 0. Assumed output was 1, so the next output will be 1. Okay, but if T equals to 1 and T equals to 1, so what will be the output? That is the inverse of the assumed output, complementary of the assumed output. So if the assumed output was 0, the output will be 1. If the assumed output was 1, the output will be 0. So that's the characteristic table of the T flip-flop. And this is the truth table which we have obtained from the characteristic table. And you all know, if there are, because it's only one input T, so how many combinations it will be? If there is only one input, so it will be 0 and 1. So you can see, if it is 0, what is the output? It is the same as the assumed output. So I have written here Qn. Okay, and if T equals to 1, as you can see, T equals to 1, what is the output here? The output is the invert, the output is the complementary of the assumed output. That means if it is 0, it is 1. If it is 1, it is 0. So I have written here Qn bar. So that is the truth table of the T flip-flop, and this is the diagram of the T flip-flop. Remember, why toggle flip-flop is used. It is not necessary to use the whole JK flip-flop if we just require the J equals to 1 and K equals to 1 condition. We will use the T flip-flop. Okay, so that is all about the toggle flip-flop. In the next slide, so we have already covered the working of all the 4 flip-flops: SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. In the next presentation, I am going to cover all the characteristic equation of all the flip-flops, how to determine the characteristic equation of all the 4 flip-flops. Okay, thank you so much.